Hey folks, 81D. Was the probability of simple random sampling 99 salmon and getting an average length longer than 23? This is very similar to the one we just did, C. So let me just put that there for a second. So longer than 23. So the only difference is we're sampling 99 salmon instead of 11. So remember when I was talking about sampling 11 salmon that the mean should be really close to 20? So getting a mean that's more than 23 seems really unlikely. And we got a probability of less than 1%, 0.0064. So if we were to talk to or sample 99 salmon, if I talk to that many salmon, I'm pretty sure that the X bar is basically going to be 20. If you understand sampling, if you're starting to conceptualize things, see if that makes sense. If you talk to 99 salmon, that's such a large amount, and it's totally random, that if you, for every really long salmon, there's probably a really short one, but the average X bar should be super duper 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 close to 20. So what's the probability that the X bar, the average, would be more than 23? That seems impossible. That would never happen. Something weird would be going on if that was the case. Okay, so I'm predicting a probability super duper 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 low. Basically zero. Seems like an impossible situation to me. So last video I showed us how to use the normal CDF function. So we just need to put the lower, the upper, the mu, and the sigma. So longer than 23. So 23 is somewhere over here. More than 23. So the lower, 23. The upper, you could be fancy and say 1 EE99, or just use the 99999 trick that I like. The mean mu is 20. And then the standard deviation, remember the new standard deviation has to account for sample size, so it's just going to be 4 divided by the square root of 99. Okay, so let me bring over my calculadora. Let's see. On. So normal distribution, normal distribution, enter. They want the lower, 23, comma, the upper, 99999999999, okay, comma, the mu, 20, comma, new standard deviation is 4 divided by square root of 99. Slide out from the square root symbol, put an end parenthesis, hit enter, and it gives me 4.28 E14. So remember, that's just scientific notation. So let me write that down over here. 4.28 E negative 14, negative 14. So hopefully you remember from science class, that's just 4.28 times 10 to the negative 14th, which means move this decimal 14 places to the left. So that would be point there. So I move that decimal 14 places to the left, and I would get this number, which we could say is approximately 0, right? It's super duper tiny. So here's what it's saying. We magically know the average length of a salmon is 20 inches, standard deviation 4. If we were to sample 99 salmon, the X bar, because we talked to so many, should be super duper close to 20. What's the probability that the X bar of that sample would be longer than 23? Oh, like you just magically grabbed every gigantic salmon, just coincidentally, luckily. Yeah, probability of that happening is ridiculously low. Basically 0. Basically that didn't happen. It's not going to happen. Okay, hope that made sense.